video is going to be your introduction to 1-2 transformations of functions. First, we have here a concept review. These are three different tables of three different parent functions. We have the linear function, which is the equation y equals x, the quadratic function, which is the equation y equals x squared, and then the absolute value function, which is the equation y equals the absolute value of x. Those horizontal bars mean absolute value. So you can see here we have different sets of numbers in these tables for the linear, quadratic, and absolute values. Those are going to be the basic points that you use to graph these different types of parent functions. And I actually have the graphs on the next slide. So there are many cases in this section where we are going to be comparing the parent function, which is what I have listed up above, with some type of transformed function, and we need to be able to graph the parent quickly. That's what these tables are for. So up here in the upper left-hand corner, you can see we have the linear function. So I did graph those 5 points that I had in the table, but notice I expanded my lines further up and further down from what the points actually were. Those 5 points are not the only 5 points on this line. They're just 5 points to get you a good picture. So this is the parent linear graph. Over here on the right, we have the parent quadratic graph. So again, I have the 5 ordered pairs from the table in the previous slide for the quadratic function, which is y equals x squared. And then down below is absolute value. And again, I plotted the 5 points that go along with the absolute value parent function. So anytime you need to graph either an absolute value, a quadratic, or a linear, you do need to compare to the parent. And we're going to be going back to these values when we work out those questions. So this is 1-2, transformations of functions. We have our essential question: what do the differences between the equation of a function and the equation of its parent function tell you about the differences in the graphs of the two functions? So we're going to be comparing original equations, the original parent equation with some new equation to tell what type of transformation is going on. Which brings us to 1a. We are going to graph the function that's given here using the parent function as a guide. So when you're doing this type of question, you want to look at the equation and determine what family it belongs to. So if I'm looking at this, I see I have an x to the second power. Anytime you have an x raised to an exponent of 2, that is going to belong to the quadratic function family, which means the parent function is going to be the quadratic function parent. So the values for the table for that were -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And there's my graph of my parent function. So now we want to look at the equation that we're given. If you recall, the parent function for a quadratic is f of x equals x squared. The new function that I have is x squared subtract 2. So if you were taking 2 away from the x squared, what do you think would be happening with the graph? Well, it seems like if we're taking away 2 from it, we're going to be shifting this entire graph down 2 units. And that is correct. Anytime you have a subtraction on the end of the x squared, you're going to take each of your points and you're going to move them down 2. And then we're going to draw in our new quadratic. So that is my equation for g of x. This function has shifted down 2 from the original. This is what we call a vertical translation. So a translation is some type of transformation of your function that's going to shift each point on your graph the same distance in the same direction. This was specifically a vertical translation because you had some number on the end of the function that is changing the direction that it goes. This is what we call our k value. If k is negative, like it was in the previous question, it is going to shift your graph down. If k is positive, it's going to shift your graph up. So now we have example 1b. Looking at this equation, I don't have a square like I did in the last one, but I do have these bars. Those vertical bars means that this belongs to the absolute value family. So the absolute value parent function in table, I'm going to start with the points, negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. So again, this is my parent. Now this one might not be as instinctive as the last one because I'm changing inside the absolute values. I'm actually acting upon the x instead of acting upon the entire function. So I'm going to make a new table of values and plug in to see how my graph is going to change. So let's start with an x value of negative 4, and we're going to go the whole way through an x value of 2. And we may not need this many values, but I want to make sure I'm using enough values so that I can get a good picture. So if I plug in the negative 4, negative 4 plus 2 is negative 2. The absolute value then of negative 2 is a positive 2. Absolute value turns numbers positive once they've been combined. Absolute value cannot change subtraction to addition or change any other signs except if there is a single number in the absolute value. So once I combine the negative 4 with the 2, then I can take the absolute value that turns into a positive 2. So negative 4, positive 2. Negative 3 plus 2 is negative 1. The absolute value would be a positive 1. So negative 3, positive 1 is there. Negative 2 plus 2 is 0. 0 has no sign, so it is going to stay 0. Negative 1 plus 2 is a positive 1. The absolute value is still a positive 1. Absolute value is distance, so it's not necessarily going to be an opposite sign, it's just going to turn something positive. And the example I've used before with this is think about if you are some distance away from some town. It doesn't matter if you're 10 miles away on the west or 10 miles away on the east, you still say, I'm 10 miles away from this town. It's the same thing for absolute value. It doesn't matter if you are on the negative or positive side, you're still that positive distance away. So there's our point, negative 1, 1. 0. 0 plus 2 is 2. Absolute value is still 2. 1 plus 2 is 3. Absolute value is still 3. 2 plus 2 is 4. The absolute value is still 4. And I do have a few more dots on one side than the other. But when I connect those out, hopefully you can see if I'm going from the black equation to the blue equation, we actually moved every single one of the parent dots to the left 2 units. Now this might not seem like it makes sense because we do have this plus 2 in the equation. And that has to do with your general forms for an absolute value, which you'll see on the next slide. Even though there's a plus 2 there, anytime you're shifting on the horizontal, it's actually going to look opposite from what it really is. And that's because the formula has a minus in it. So this isn't necessarily x plus 2, it's x minus negative 2. And that negative 2 is going to be your horizontal shift. So up at the top here, if you have a number that is acting upon the x inside of either parentheses or some other type of grouping symbols like absolute value, the graph is going to have a horizontal translation by your h units. And then we have this. These are some general forms of quadratic and absolute value, and I will scroll a little bit so you can see the end of what it says here. They are both set up the same way. They both have a y equals and an a out in front. We'll be talking about a more in the next video for this lesson. Then you have either absolute values or parentheses, x minus h. There's where that minus comes in that I was talking about. And then at the end, plus k. Make sure for the quadratic you do have the square here, and then the plus k on the end. So we did our example with k first. If k is positive, your graph is going to go up. If k is negative, your graph is going to go down. Now h, you have to think about h as being opposite from the equation. Because if this said x minus 3 in the absolute values, your h is a positive 3. If it said x plus 7, your h is a minus 7. So for h, get a little bit more space here. For h, if you have a positive number, that is after you've taken the opposite, if you have a positive number, your graph is going to go to the right. If h is a negative number, it's going to go to the left. And we're going to look at 4 equations on the next slide where we're just going to name what family they belong with and the movements that they have based on the values of h and k. So again, you really need to think about h as being opposite. K is just whatever the sign is. K does not change sign at all. Okay, so we have A through D here of these examples. So if we look at A, we have bars here. That means that this belongs to the absolute value family. Your h value, well, you see I have an x minus 3 in here. Remember, h is actually the opposite of what it looks like. So your h is a positive 3. That means that your graph is going to the right 3 units from the parents. Your k is whatever's on the outside. That is a 4. K is your up and down movement, and because this is positive, your graph is going to be moving up 4. So h is 3, k is 4. It's moving to the right 3 and up 4 from the parent function. Again, these directions, when we say right and up and down and everything, that is with the parent in mind. Part B, we have parentheses and we have to the second power. That means this has to belong to the quadratic family. This h value, again, I'm taking the opposite of what's in the parentheses, so that would give us a positive 6. That means our graph is moving to the right 6. K is whatever's on the end, so k is going to be a negative 2. That means that this graph is moving down 2, because it had a negative k. Part C, back to those bars again. That means this is an absolute value. Your h is the opposite of what's inside those bars, so your h is going to be negative 4. That means this graph is moving to the left 4 units. Your k is 5. That means we are moving up 5, again from the parent function. The last one down here, this is another quadratic. Again, because you have the square, your h, opposite of what's in those parentheses, so that's going to be a negative 2. That means our graph is moving to the left 2. Your k is negative 7. That means that this graph is moving down 7. So I hope this was helpful to help you look at the h's and the k's and how your graph can move in different directions. We will be continuing in the next video looking at reflections and dilations. Dilations are where you're stretching things out or compressing them to make them smaller. Please go back and rewatch anything that might not have made sense. We will be doing some IXLs on this section as well. So look for some more videos for those later on, and contact me if you have any questions.